Welcome to episode 23 of Renewing the Conversation, a series of interviews where we talk about renewable energy and heating.
Today, welcome Simon Smith from SA Energy. We speak to Simon about solar PV and home storage batteries and discuss some of the most common misconceptions about home solar and whether it really helps you in the event of a power outage.
Don't forget to hit the subscribe button below and please show us your support by giving us a thumbs up. Enjoy the interview.
Hi Simon, good morning. Thank you so much. On this beautiful sunny day, I gotta say I have been missing the sun so much, not to mention the fact that my laundry has been piling up and today I get to do my laundry. So we're very happy that it's a good sunny day today. We want to crack on and ask you some kind of in-depth, get into the nitty-gritty of solar, because I think that we're all kind of familiar with solar panels, and you order some solar panels and they go onto your house and hopefully it's a good sunny facing roof and that's it, and hopefully it starts to kind of lower your electricity tariffs later on. But I wanted to get into the kind of more technical aspects of solar and how you can set it up differently. So last year we had Storm Arwen. Now we have a big solar array on our roof, and Storm Arwen came barreling through. We lost power. We had power for, I think we were out with for 2 days, but there were parts of the country that didn't have power for 12 days. And we have friends and family, when we were speaking to them on the phone and we were telling them and giving them updates, and they said, we're a bit confused. Why don't you have power when you've got solar? And this triggered a really interesting conversation. So can you please explain to us what happens when you have solar, and does it always mean that you are off the grid?
All solar PV systems that are AC coupled, so in other words connected to the grid, have to be able to disconnect during a grid failure. And there's a number of reasons for this, but the most important one is you have to imagine there could be some poor guy working down the line somewhere and thinks that line is dead because substation's off or whatever he's doing, and there's a few houses at the end of the line all pumping out a nice bit of output from their PV system. So there's no way of isolating it. So all on-grid inverters need to be able to isolate off. That's been the case since forever. If you have a substation fail, that's great because it isolates everything off. So you probably experienced a case where lines were dropped, so cables literally fell off poles or trees have fell on or something like that, and everything's designed to shut down. So you must be able to turn off everything going back the other way. Otherwise, there's no way for the system to isolate and make those lines safe.
Just in layman terms, you're a homeowner, you buy solar, the solar panels go on the roof. What does that mean exactly? Does that mean that that solar is charging and creating electricity that then feeds into your house, and then when the power grid goes down and you have no power, those solar panels do not work, because obviously what's starting those solar panels working is electricity from the grid?
Slightly the other way around. So the inverters generally work by being powered from the DC. Almost all inverters will have a small parasitic load on the grid, so a small amount of energy that they take just to keep them in standby mode so they can keep checking if there's DC power there. But basically, once the DC is there, the inverters are effectively self-powered by the energy that they're generating. All inverters generate power at a slightly higher voltage than the grid, and there are limits to this. We can only go up so high and we can only come down so low, and they're all set within the G98 settings. Of probably a little bit too much detail in that. So you can think of it as two opposing pressures. So your inverter's pushing that way against the house, pushing power in, and the grid's pushing the other way. Most of the time, we've got more power coming in than more force coming from the inverter than you have from the grid. So we power the house and push out to the grid. So the inverter effectively will always power the house first, and then any excess will go to the grid. So that's the way it's always worked. That's how you get export energy. So in a grid fail situation, we no longer have the ability to dump that energy anywhere. So imagine if your inverter stayed online, we can no longer push energy out to the grid because there's no load there. The inverter theoretically could create its own grid voltage and then power the house, but there's nowhere for the excess energy to go, and it can't downregulate itself. So it can't, in other words, dim itself down. It has to continue running. In reality, what they do is they just shut them down. It's just safer all round.
Is it the inverter that's the linchpin or the safeguard in this whole system? Is that what basically acts as a safeguard between the PV going into the grid when there is an outage?
Correct, yeah. So those protections are built into the inverter. Often if you go and stand by your inverter when it's starting up, you'll hear it clunk and click away. And that's a load of relays and contactors inside doing what they call a grid test. And they drop in and out so that they can test that all the circuitry is still working and it can safely turn on and off. And then it plonks in and away you go, start generating, lovely little hum, and off we go. But yes, all of those protection settings are built into the inverter in line with the local regulations of whatever country you're in.
When a salesperson comes to your home as a homeowner and says, you know, we'd love to install solar here, this is the right roof to do it on, these are how many panels you need, does every one of those sales have to have an inverter? Is an inverter just part of the package straight away?
Yeah, one way or another, you're going to have an inverter. There's no way of doing it any other way. You're generating DC voltage, so think of that like generating power from your batteries, from AA batteries or something like that. That's DC power. When you are obviously connecting to the house, you need AC power. So an inverter, that's literally doing that job. The name of the product is the name of the process. It's an inversion from DC to AC, and it's using the incoming grid as a reference so that it can set itself up to whatever voltage, frequency, etc. it needs to be. It doesn't matter if that's a box in your loft, garage or whatever, or if it's a micro inverter behind the panels. They're all doing exactly the same job in one way or another. They're all converting DC to AC energy.
So the basic package for a homeowner is going to be solar panels, which is like a PV array, then an inverter. That's your basic, the starter pack. Is that correct? And then do you kind of go up from that? So then you start to consider other things like potentially a battery storage, etc.
So once you've got your power being generated, and depending on the size of the system and your energy load in the house, the vast majority of domestic properties will be exporting energy. We don't really want to do that. What we want to do is utilize as much of that power as we can, especially at the moment. Energy rates are nuts, as we know. So we want to use every single kilowatt hour that system is generating. To do that, you have to come up with ways of storing that energy. Traditionally, so since 2010, we've been doing that by dumping energy into hot water tanks. So the hot water is a thermal store. It's a way of storing electrical energy in a heat battery. That's what that is. Nowadays, we have the option of putting it into battery storage, whether that be a static battery, a fixed battery in your home, or a electric car battery, an EV of some sort. They're effectively the same difference. The biggest challenge is how you control that energy flow. With a car, there are certain minimums you have to be able to hit in order to charge it up from the solar PV, from excess energy only. Whereas with a stored battery, a fixed battery, you can charge it up from almost a few watts right the way up to the full capacity of the PV array or the charge control circuit.
Addressing your point with Storm Arwen and the subsequent storms, I think it was Eunice and one of the others. We saw a lot of people online that had battery packs now connected to their solar PV. They thought that they were sitting happy and that there were going to be absolutely no issues with regards to them staying online. Unfortunately, a lot of them had the same nasty surprise. The grid went out, their batteries ran to a certain point and they were not able to recharge via the PV. Why does that happen?
Okay, so it's exactly the same reason of the PV. You can consider the battery as a panel. It's all the same thing. They're all generating DC power in some way or another, and they're all going into an inverter. That inverter in turn is connecting to the grid, and therefore the same rules need to apply. We cannot have equipment hanging on the grid that can generate power and put it out to the grid during a grid fail scenario. It has to stop. In order to continue utilizing that power, you need to have a set of relays that will allow a certain output. Now, most of the modern AC coupled and hybrid inverters that drive battery systems have got this built in to some degree. They're normally limited to around 2 to 2 kilowatts of maximum load. So it's enough to be able to say, plug your fridge freezer in and keep your food frozen and keep the lights on or something like that, maybe some small power stuff. You're not going to be putting the kettle on and running the oven, but it's enough to keep you going. And that's the sort of standard that's going out at the moment. There are one or two exceptions where you you can go a lot more higher loads, but you also then have to start considering energy capacity as well.
So just to be really clear, because I think that there is a little bit of confusion, because it is quite complex actually.
Very complicated.
I think that even I have been taken aback because we put solar panels in, and we put them in a few years ago, and they've worked beautifully, and they have been so uncomplicated. There's been nothing to do, no maintenance, nothing to even think about. And now when you start to get into the nitty of, okay, hold on it, what does this really mean in different aspects of your life? For example, if there's a power failure, now it starts to become a wider conversation. And I think that it's just a conversation that we need to be really clear on. So for homeowners that have purchased a solar panel and have got a solar panel system with an inverter, if there is a power outage and the power goes down, like a storm or wind situation, 2-3 days of no power, you will lose power in your home. You will not have power.
Yes. Correct.
If you have a solar panel, an inverter, and a battery, your battery hopefully will have got some stored energy in it. So your home will run off that battery until that battery depletes to zero. And then you also be affected and have no power.
Yes, with a small caveat. In order to be able to run off that battery system, your inverter must have an emergency power supply, often referred to literally by its acronym, EPS. And that is often just connected to a little double socket next to that inverter for the battery pack, and allows you to plug in an extension lead and keep your freezer going and your lights on. There are more complex layers above that. You can then you can have special changeover switches put in, so you can manually switch it over, which means you can then feed the whole house from it, but you would have to manage your loads. And by that I mean, don't turn the oven on because you've only got a couple of kilowatts of output from this inverter. There are automatic switches, but it starts to get really expensive when you start looking at those types of setups. So you have to weigh up how you're going to utilize that power and the likelihood of total grid failure for a long period of time. So obviously the storms, especially up in Scotland where they lost power for such a long period of time, it's quite an extreme case. And in a situation like that, the majority of these inverters, which are retrofitted at this point, so the majority of battery storage systems are retrofitted, they're pretty much all AC coupled, which means that they are separate from the main inverter. You are limited to that inverter, to that battery capacity, and the capacity of the PV system to have been charging it. When do we get storms? In the winter, generally speaking. When do we lose most of our grid feeds? In the winter. So you kind of have to take the weather warnings that we get, pre-charge your battery and not discharge it. Now you can choose to do that from the grid for your emergency backup. That's great. But you will still be limited to the capacity of that battery. And quite frankly, 3 to 5, 10 days, whatever it's been up there in terms of power loss, you're not going to get that out of a standard 5, 6, 10 kilowatt hour battery pack. It's just not going to happen. If you're looking for a solution that's going to give you a long-term grid backup, especially in winter, it gets a lot more complicated. There are systems we do. I've literally just fitted one last week, actually, which is a full grid backup with batteries and keeps the inverter going and grid fail and all this wonderful stuff. Still quite a small battery array, but we have the benefit of being able to keep the solar PV system alive. Just to go back to the difference between AC coupled and hybrid inverters, if I may. An AC coupled inverter literally sits there and monitors your grid connection for export energy. And as soon as it sees any export energy, it mops that up, puts it in the batteries. When it sees you importing energy, assuming it's got capacity in the batteries, it'll try and match that import. So you're at zero import, zero export. That's what we're trying to do. Similar to your hot water controls for storing energy in the immersion heater through the hot water tank via the immersion heater. If you're using your battery to its capacity, it will pull in more energy from the grid. And that's effectively what an AC coupled does. When you're running entirely off AC coupled, you can only take energy from it. You cannot put energy into it. The difference between that and a hybrid inverter is the PV panels are connected to the hybrid inverter, and the inverter can use both the PV energy and the battery energy in effect during a grid fail situation to maintain the output. You can run the household loads off that again, 2 to 2.5 kilowatt output from the battery store and from the PV during the day. And what it will try to do in most cases is manage the load to the house from the PV system, and excess PV energy then goes to the battery. And then the same situation occurs if your loads go up over the PV generation, it comes out. So effectively, with a hybrid inverter, you can run for longer. You're still going to be limited. Again, we have to go back to when is this likely to be needed? And that's going to be the winter months, to be honest. And it's going to be in the middle of a storm, bad weather. Your PV system is not going to be generating massive amounts anyway. So we have to be realistic. The standard retrofit or even newly installed battery systems are great for, I'd say, 1 or 2 days. You'd get away with it a little bit if you're very frugal with your energy use. However, they're not going to see you through a 10-day power outage. It's just not going to happen.
If you're very rural and let's say you don't have PV and you're very concerned about this, I assume you're going to have the same issues if you try and plug a generator into the system. You're going to have the same problems if you've got a battery and you're trying to recharge that battery maybe with a generator or something like that. Will you still run into the same problems?
With a generator, there are certain makes of inverter manufacturer that you can use that will allow you to power the system via a generator or via PV or via battery. So you'd be looking at SunSync, Victron, SolarEdge, just off the top of my head. I'm sure there are others and we'll get comments about that later. But all of those are able to do that straight out of the box. The SolarEdge is a little bit different. You do need to have a small piece of external equipment, but it is designed in to do that. Victron has been around for a very long time for off-grid design, for off-grid installations, power installations, very big in boats, camper vans, that kind of thing. All of those will take multiple sources of energy input, which gives you that longevity. And the reality of it is, in most cases, for long-term running, you are going to need a backup generator of some sort. So yeah, generally speaking, if you need the facility to be off-grid for any length of time, then a generator is something you want to have kicking around. We are only talking about running very small amounts of power. Again, fridge, freezer, keeping the lights on. The reality of it is, unless you're going to invest a huge amount of money in battery storage and have redundancy in that system, you're going to really struggle to be permanently off grid.
I noticed that one brand you didn't mention, which has been spoken about an awful lot and very, very popular in everybody's top of mind of brand awareness, is Tesla. So Tesla have also got battery storage. I think it's called a Powerwall.
The Powerwall 2 now.
Powerwall 2. Oh, very fancy. And
we'll wait for the
3. Exactly. You just bought the 2 and the 3's coming out. I believe that Tesla is slightly different. Can you just tell us a little bit about why the Tesla Powerwall 2 is different, a whole different animal altogether?
I'm going to disagree with you slightly there. It isn't a whole different animal altogether. What Tesla have done, and quite cleverly, if you ask me, is they've packaged the battery up, which is true capacity. It has a built-in inverter, so it can stand alone, or you use the Tesla Powerwall gateway. The gateway has all those magical bits and pieces I was talking about that isolate you from the grid. So that's all built in and does its thing. So in a grid fail, the Tesla gateway isolates you from the grid, allows their battery system to continue running. You can, in most cases, run the inverter with them as well, but there are still limitations because you can't turn the solar PV inverter down. There are control protocols that you need to have in place to stop the battery system overcharging. So it will work, and it works quite well, but you have to be a little bit mindful of how it's managing the energy. The way they're winning really is in what they've created around the gateway, which is the software in the back end. So they're doing some of the thinking for you up ahead. So they're looking at weather prediction and therefore assessing likelihood of fail. And you can set dynamically the amount of backup energy you want to keep. So if you've known, if you've lived in a place for a while, you've probably got a good idea of how often you're going to lose power and how long that tends to happen for. So you can plan for that. You can say, okay, well, it's pretty likely that tomorrow it's going to be quite windy. We're likely to lose power 3 hours. I need 40% reserve capacity in my battery. And the Tesla can do that. You tell it what you want it to do, and it will just monitor the weather patterns and all that sort of stuff and do it for you. Brilliant. Absolutely brilliant. No problem at all with that. And that works quite nicely. It is a good little setup, great little portal to use there. So there's no problem with that.
So is the gateway the kind of game changer in Tesla and, you know, all of your other kind of brands? Is that what kind of sets Tesla apart, is the fact that it has these clever things like the weather monitoring and everything built in, but then is the gateway built into the Powerwall too?
No, so the gateway is a separate piece of hardware.
Right.
So you have a little, well, it's not little, it's a chunky little box that all the so your main feed from the meter goes into that box, and then out of that box goes to your fuse board. So it's like another piece of kit before you get power into the house, and that controls when the grid goes out. You can split the loads in that as well. If you planned for this for a backup system, what you would do is you would have what we call critical loads and non-essential loads. So your non-essentials will be things like your heat pump, your EV charger, your oven, probably, you know,
Hairdryer.
your Arga. Well, yeah, we can't do without the hairdryer. You know, got to be reasonable here. We're not animals. But you know, if you've got a big old Arga, electric Arga, or something like that, you don't want that running off your battery pack. So anything like that that's quite heavy load, you get rid of. So that stays on the non-essential loads. Your critical loads are your small power, your fridge freezer circuit, your lights. Keep those things going. Keep the broadband going. You know, if you're going to be stuck in the middle of nowhere, at least you want Netflix. It's for running those things. And that's what the Powerwall does. What the Powerwall gateway does. It allows that separation. You can just feed it straight into the main house and then manually control your loads. That's fine as well, because sometimes in a domestic situation, it's not really practical to separate the fuse boards up. There's often not space, or just the cost of doing it and separating those circuits out is difficult. So I often suggest when people are doing new builds, self-building, that kind of thing, plan for that kind of setup. You don't necessarily need to use it, but just do that from the outset, and it will save you a lot of grief later. There are fuse boards out there, dual row boards and things like that, that are big enough to do it. So think about that when you're planning your electrical system. The gateway control has all of that automatic transfer switch. You'll hear about that quite a lot. It's called an ATS, which is a pair of contactors that switch you over and make you independent from the grid. The difference here is you're not manually doing that. You're not deliberately doing it. It's doing it in grid fail. And then it monitors the grid. When the grid comes back, it will kick back over, start pulling power from the grid as usual. It's pretty much seamless. You wouldn't really notice it as a day-to-day thing.
Does that then keep you going in a long-term power fail, or is it just the same thing as?
Exactly the same. Yeah. All comes down to battery capacity. If you don't have capacity available, if your battery's dead, when that power kicks over, that's it, the lights go out.
Yeah.
If you've got a bit of power when it comes over and then you drain that battery down, the lights go out. They can't just create power from nowhere. The only way you can do that is either with the solar PV, a wind turbine if you've got that option, or with a fossil fuel-based generator of some sort. As far as I'm aware, and I'm probably going to get corrected on this, but I don't think the Tesla Powerwall can take a generator feed at this point.
Does the gateway box go in? Does it have to be inside your house next to your EV box, next to your electrical fuse box?
The consumer box, yeah.
Yeah, so you want to put the gateway as close to the fuse box, so more accurately, as close to the meter as possible, really. Mm-hmm. You're still limited by electrical regs in terms of length of cable from meter point to the first serviced item. So there's a whole thing about being 3 meters away, needing a fuse and all this sort of stuff. But if you're already in that setup, you'll already have that kit in place. So it's just a case of interrupting that. There are a couple of link wires that go from the gateway to the Powerwall itself. So obviously you've got to consider that in terms of routing those wires. And that will probably be the same with any of the new ones that are coming out. I do know there's a couple of other manufacturers that are bringing theirs out. Give Energy are bringing one out soon. Those are all coming out with very, very similar setups with gateways. I believe Solax are going with a fairly much combined piece of kit, but until I see it physically, I don't really know. And I believe the Give Energy system will be a separate box, very similar to the Tesla setup.
You are paying a premium for the Tesla Powerwall too. So in terms of pricing, is it comparable then to go with the system you mentioned, Give Energy? Is it possible to get a Give Energy system with all kinds of bits and pieces, maybe from other manufacturers, to put together a bit of a hybrid system, if you like? Would that compare favorably financially versus just going strictly with the Powerwall 2 and its gateway?
The short answer is no, and the long answer is yes. So the Give Energy system is significantly cheaper than the Tesla Powerwall, even if you stack the batteries to the same capacity or higher. In reality, it'd be a higher capacity. Give Energy do their batteries as actual load. So the 8.2 kilowatt hour is an 8.2 kilowatt hour battery. So they've taken into account what we call depth of duty. So that's the amount of energy that needs to be left to protect the batteries from themselves so they don't damage the chemistry in them. So you can put a couple of those in with a couple of their AC coupled inverters, and it's going to come out cheaper installed than a Tesla Powerwall. And it will be 3 kilowatt hours more capacity. So that's 16.4 compared to 13.5, I believe it is, in the Powerwall 2. Personally, I'm a big fan of manually switching over. The automatic transfer switches are okay, but if you don't have a good indication of what's going on, you don't really know, so you may not control your loads.
Interesting.
That's something to consider. So I quite like the idea of having it fail, the lights going off, and you being well aware that there's now a problem, because you can now manage that situation.
Especially if you were away from home at that moment. So you could be out in the supermarket shopping, and if, as you said, if it automatically switched over to your battery, you could not need your TV lights and all those things that you've accidentally left on.
Even more so, we've got an air source heat pump running. That battery could get killed within like an hour.
And
you get home to your battery being flat. So actually, that's a really interesting point. That actually making it go down, and then you have to go and switch it. It gives you a lot more control, doesn't it?
It does, and it gives you that mindset to now start being, managing your energy, being frugal with it, because you now know you're on a limit. You will check your battery capacity at that point. You'll make sure that you've got what you need running and the absolute bare minimum running. You'll know what your local conditions are. Is this just a temporary outage because a line works, or is a substation trip? It's all going to be sorted in an hour, who knows? Or are we in the middle of storm Doris or whatever? And there's got to be a Doris somewhere, sure. It's all well and good, for example, if these things are sending out alerts to your mobile phone, that's great. But what if you're in an area with no mobile signal and your router's down? Because the other thing you don't want is your ATS system, your automatic transfer switch, which has been sat there doing absolutely nothing for a couple of years, actually not working when you need it. And that can happen. They are physical contact devices. They can fail. There's something quite satisfying about just going to a big old switch, plunk, switched, done. You're isolated from the grid. You're on your own. Do what you got to do. If your batteries fail, fine. Plug the generator into that supply and away you go. It's not going to matter.
You don't sound overly kind of enthusiastic about Tesla. Brands that you really love and that you just feel offer the homeowner the best tech at a good price and is really reliable and robust. Which are the brands that you think that homeowners should really kind of be thinking about?
I would suggest that at the moment, for a straightforward AC coupled installation, you're going to find it difficult to beat the Give Energy setup. There are a couple of others. Pure Drive's pretty good. And the Fox CSS offering is pretty good as well. But I pretty much always default to Give Energy. It's the least hassle from an installer's point of view, really straightforward to put in. The backup and service from them is exceptionally good, and that's really important. And their flexibility. The majority of battery systems are much of a muchness. It's a bit like comparing solar panels. It's kind of a waste of time. A panel's a panel is a panel. It doesn't really matter. What matters is output per square meter when you look at solar panels. That's all that matters. When you look at inverters, it becomes a slightly different discussion because it depends on the type. And I'm a massive fan of Solar Edge. That's no secret there. Look at my LinkedIn. I'm a huge fanboy when it comes to Solar Edge. It's a brilliant kit. And when it comes to the battery storage, I think the Give Energy is way ahead. And the main reason I think that they're way ahead is actually the software. It's not the hardware. I can go to Give Energy as an installer and say, I've got this really weird setup where the client wants to do whatever, and we have had some pretty odd requests, and they will come back with a development. They will alter their software to suit that particular plant, or they will provision a piece of hardware for me that will do the job. I cannot go to any other manufacturer, have that conversation and expect a response literally within days and sometimes within hours. It's brilliant. When you talk to somebody like Solar Edge. If I say to them, I need to do something weird with the way your batteries are set up, they're not going to do anything. And quite rightly so from their point of view. They're far too big, and to redevelop and put out specialist one-off things is going to be very difficult for them. Tesla are never going to listen to anybody from you. They don't care. They're just churning out stuff. That's fine. That's their market. And it's much the same for all the rest of them. I haven't come across, even Solax are incredibly difficult to deal with if you need anything specialist done. Software will win every time when it comes to how a product is used. And we are in a different phase of energy use in this country now because of the energy pricing. So if you're on a multi-rate tariff, there's an argument for installing a battery on its own. You don't need PV, and you're going to charge that battery at low rate energy and discharge it when the energy is expensive, or do a bit of grid aggregation, so buying and selling energy. That's fine. That works very, very well. And the model is there. It does work. But you need a really good bit of software in the back of it that will do that. I believe Give Energy were the first ones to actually tie up with Octopus to use their API with their Octopus's programming interface and Give Energy. They talk to each other. They can use energy pricing forecasts and things like that to determine when to charge and discharge. It doesn't require an input from the user other than setting up minimums and maximums and what you want it to do. It's a super flexible thing for the homeowner to use.
I think that a lot of people think that electric vehicles are going to be a solid with regards to technology called vehicle to grid or vehicle to home. Is that something that is realistic, and is that something that's going to be feasible to help drive homes in the event of power failures, or just to try and utilize cheaper tariffs?
Vehicle to home, you've kind of already got that, I think, in the Hyundai Ioniq. I believe they've done it. I've probably said that wrong. I think they've got a power output on that. It is quite small. I think it's less than 2 kilowatts, I believe. But yeah, theoretically, absolutely, it would run, again, small power, keep your fridge going. Vehicle to grid, now that's been underway for quite a while. I believe that's pretty much been driven by Nissan. They do have a vehicle charger that will do that. It's a big old lump of a thing, but it does work. I'm pretty sure that the Tesla Model 3 and the Model Y have got vehicle to grid capability, but not enabled at this point. We do have an interesting problem in this country in that the technology tends to outstrip the speed of the regulations. So I suspect there's an awful lot of regulation questions there. And there is a question as well around the load management of those battery systems. There's a huge difference between how you manage a traction battery, so the battery in your EV, as to how you manage the battery pack on the wall in your house. There is a little point with the EVs as well, to do with home charging and excess energy. If you plug your EV in and your batteries are full, your static batteries are full, it'll drain them down and charge your car up. That might not be what you want those static batteries to do. So you have to be very careful about how you set that energy system up. There are ways to avoid it, but you might have to put a little bit more effort into the setup initially. The other argument is, well, energy's energy, and if I've charged my batteries overnight, if I've charged my batteries either with cheap energy overnight or with the solar during the day, come home at night, well, I've got 8 kilowatt hours of energy for nothing or very cheap. So it kind of depends how you look at it. But also, if you're going to use one of the smart chargers, such as the Zappi or the Solar Edge inverter with EV charger integrated, or their new external EV charger, smart charger, you have to consider the limitations of that. So your PV system would need to be generated, I believe it's at least 1.6 kilowatts before it'll start to trickle charge the car, if you will. That's its lowest amount of energy allowed to go into the vehicle. And that all the way up to 7 kilowatts, standard single phase charger. So that's a big old PV array. It also means that that car is now taking all of your excess energy and there's nothing left to charge batteries or do hot water. So you have to consider these things as an overall system, not as I'm going to have batteries and an EV charger and a hot water controller. If your PV array is 3 or 4 kilowatts, something's going to give. You're not going to be able to do all of them. So it's really important. I mean, we've got between the two vehicles, 125 kilowatt hours of storage. I've got a 10 kilowatt PV array. That's never going to charge both of those up. It isn't. I'd need probably 150 kilowatt PV array. I'd see very few domestic properties that have got the space and the budget to put 150 kilowatts of PV, especially not a 3-bed semi in the middle of Fareham. That's not happening. I think my point is more, you have to look at these as an overall system. This is where data comes in. Just going back to my earlier point, if you don't know what you're exporting, it's really hard to determine the size of system. And I would always caution people to consider what they're going to do in the future. If they're going down the EV route, is a static battery store really the answer for you at this point? Because you might find you don't have enough energy to run it, or you have to rethink your expectations. And I think that's kind of key as well. Understand fully what the system will do and make sure your expectations are being met. These aren't magic. They have to get their power from somewhere. And if you're using it all up to do something else, there's no power there for it. But this, again, you must be doing things like thinking smart meter needs to go in. I know people get all squirrely about it. It will give you that data. And more importantly, it will give you access to split rate tariffs and multi-rate tariffs. Not to belabor the point, but we're probably heading into a time when we're going to see half-hour billing systems for domestic, similar to commercial setups. So having the smart meter in place now, ready for that, is going to give you many, many more options later in terms of controlling your energy costs. It's really key.
So we know that batteries can be a bit temperamental, especially in big temperature variations. So is this something that should be a consideration as to where you put those batteries? And I've also heard a term bantered around called thermal runaway, which probably has nothing to do with this, but is that something that homeowners should be aware of and taking into account?
I often see batteries being installed in loft spaces. To be fair, it's been a problem with solar inverters as well. I'm really not a big fan of it and go out of our way to try not to do that. Sometimes you don't get a choice. It is what it is. But if we can avoid it, we do. The reason being that your loft can get ridiculously hot in the summer months, to the point where you stick your head up in the loft to have a look for something, you'll be sweating straight away. It's horrible. It's not a good environment for electronic equipment. It's not a great environment for your battery systems. Now, all batteries, again, it's a design issue. They will have a temperature range and tolerance to them. So if you're in the Highlands of Scotland and you're going to install a battery outside, you might want to think about putting it inside an enclosure that's insulated, because most battery systems are going to struggle in negative temperatures to charge up. They will simply stop charging to protect the battery pack. Similarly, if you mount your battery system on a south-facing wall that's painted white with a marble pathway in front of it, it's probably going to get a bit toasty and it'll stop working. Same goes if you put it in a loft. You've also got to consider the installation method behind putting these in. Some of these batteries are quite lumpy. They're pretty hefty. So if you look at something like Tesla Powerwall, I think it's 102-ish kilos, something like that. Solar Edge Energy Banks, 120 kilos, I believe. The Give Energy 8.2s, 103 kilos. These aren't easy to move around. I mean, I've got specialist lifting equipment to move it. Get that up in the loft. So you're going to need a winch system. You're going to need a proper deck up there to take that weight. You're going to have to be able to work in a safe method. And I know there's people out there who'll just wander across the ceiling trusses all happy and crack on, but I'm not doing that. And,
no way.
And as a homeowner, I would caution against it, especially in a modern build where you've got these really thin built roof trusses and things like that. They're not actually designed for storage. They're designed for access. That's it. That's all they're for. You put that up there with a deck on top of it and then run that out. It's a risky place to be putting equipment.
Yeah.
So that's a safety from an installation point of view. From a temperature point of view, it's going to get hot up there. It's going to shorten the life of the control electronics. Probably not the battery, but the electronics themselves. You run your computer on a hot day, it's probably going to be slower than it normally would be because silicon hates the heat. It's one of the paradoxes of the solar panels, Why do they not work great in the desert? It's because they get really hot. So they don't work too well.
Wow.
So you do that to control electronics in your inverter, your battery pack, BMS, all that sort of stuff. It's going to get slower. It's going to receive some damage and it will shorten its life, is long and short of it. You then get into the safety aspect of it. What happens, God forbid, should everything go horribly, horribly wrong and your battery pack fail? If your battery pack has a catastrophic failure and the lithium cells start to break down and ignite, which can happen, it's pretty rare, but it can happen, you've got a really big problem on your hands because you can't just put that out. You see that a lot with the car fires. So There's lots of experiments with the best way to do it. And most of the time it involves rolling up with a great big skip and putting the car in a lot of water and leaving it till it cools off. A bit difficult when the battery's in your loft.
Wow.
So it's not to put the fear of God in you, but it's certainly to make you aware that there are certain risks intrinsic with it. And quite frankly, in a domestic scenario, I suspect that the risk to life far outweighs the risk to property. The chances are the fire brigade is going to clear everybody out, and they might give it a go at putting it out. But I think at the moment, it's just, well, we'll just let that burn until it's done. Because there's not a lot you can do with it. Frankly, if it's in a loft space, there's not going to be a lot of roof left by the time the fire brigade get there anyway. In a battery store, probably the biggest point of failure will be the actual BMS, the battery management system, allowing overcharging or excessive discharging of the battery, which causes temperature spikes. Apart from some of the really cheap garbage ones, pretty much all of them have got temperature management, so they know what the temperature of all the cells are, the average voltages of each, in fact, what the exact voltages of each of the cells, and they'll shut down the battery if they see anything that's not as it should be. And that's great. That's exactly what you want. Design and installation method will resolve most of these problems. Yeah, we know we like to stuff stuff in lofts because it's out of the way. You don't have to make special arrangements for it. But think about the actual long-term benefit of installing it in a better position. Imagine shoving 100 kilos of battery up in the loft. And bear in mind that a Powerwall and an energy bank won't fit through a loft hatch, so they're not going up in a loft. I could get a Give Energy battery up there, and probably a Fox or a Pure Drive if you really, really wanted it. I know you can get Solax batteries through most loft hatches, but it's a really bad idea. And then what happens? You're not going to just get it up there. What happens when you've got to replace it? You've then got to get that down again. And that's, you're just increasing risk constantly. And we're supposed to be de-risking these things. So let's try and make life a little bit easier, put them in a more sensible location, let them ventilate, and just understand what the implications are long term, really.
So last question before we let you go. Just quickly, top of mind, what should homeowners, when they're thinking about installing solar for the first time, whether it's solar with the inverter, a battery or not a battery, or so what are the first things that they should be asking themselves? Because you did mention earlier that the biggest thing is to just really manage expectations and qualify what those expectations are, so that as a homeowner, you're able to convey your needs and your requirements to the installer, but then also once the job's been done and the installer's gone home, you've actually got what you thought you were buying. So what should you be asking yourself, and what should you be really thinking about?
Okay, before you even speak to an installer, you need to understand your energy demands. What are you actually doing? What can you do to minimize those energy demands? So it's no different to when we're looking at heat pumps. Thermally insulating your home is a no-brainer. You put your insulation in because then your heat pump's cheaper. Let's think about what you're actually using your power for. When it actually comes to PV, the panels now are so cheap and the installations are so cheap, relatively speaking, your actual energy demand isn't really a huge question. It's actually more a question of budget. My general response when somebody says, how much PV should I put in? Which is my most common question. How much PV should I have? It's as many as you can fit on the roof. What's your square meterage and where do you want them? Put on as much output as you can, because what that will buy you is options. Sure, you might not use all that power now. That's fine. But what are you going to do later? What are you going to do when you've now got budget to buy your battery? What are you going to do when you've now got budget to plug your EV in? It's not necessarily about what you need right now. It's what you need in 4, 5, 6 years' time. So always go bigger than you think. Don't buy a standard 3 kilowatt, 4 kilowatt system. There's no need. Be patient. Understand that there is a process behind to allow connection. So, DNO application, distribution network operator applications for connection for systems over a certain size. It takes time. If you're desperate to put a system on, you're probably going to make a poor choice that you'll regret later. I would say that the majority of the clients that I have that rushed into the feed-in tariff in the early days are now coming back and asking for bigger systems. not just because they can afford it, because they're getting this lovely feed-in tariff payment, but because they now realise that what they were told 10 years ago is absolutely right. They need to go bigger. That's now the case. The more power you generate for yourself, the more choices and options you have later. If you're going to look at batteries, be aware of how you're going to utilise that energy. If you're looking for grid fail backup, just understand that it's not magical. It needs to get its energy from somewhere, and what you have will be limited. It's not going to be like a large-scale commercial system. If you want that sort of thing, you can have it, but have some deep pockets. Some of these systems are 30, 40,000 pounds to do full grid backup. It's about being realistic. If you've got a 2-bedroom terrace, you're probably going to get a couple of kilowatts on the roof. So do you really want to spend a small fortune on a big battery system? Probably not. You probably want to think more about what can I do to minimize my energy usage.
Yeah, and I think it's more about, just thinking about as you said, I think that having that foresight about what are your requirements going to be 2, 3, 4, 5 years down the line. Are you somebody, for example, that is concerned about climate change and you're in an exposed area, so you're thinking that potentially storms are going to get more brutal where you are, and so you are trying to plan and buffer yourself against really long power outages years down the line? Or are you just someone who, as you said, is in a small house and you just want to try and manage or soften the electricity tariffs that we're all facing at the moment, subsidizing yourself with a little bit of solar? So I think it's just about really sitting down and as a family talking about, especially if you've got kids, for example, you might only have 2 or 3-year-old kids at the moment, but 5 or 6 years and you've got kids that suddenly are using multiple devices and they're charging multiple devices. So you've got to kind of take into account your expansion as a family and your expanding needs as a family. It's an area of your home that really requires a lot of forethought and careful consideration for the future.
And I think it's a great teachable moment. So all my kids are well aware, and I don't know if you've ever seen my LinkedIn, my daughter came out and did her work experience with me, hence the Captain heat pump and the renewable energy kid. We just did that for a laugh and it's kind of stuck. And she loved it. She's got a really good, strong awareness of where energy comes from and what it costs. And to be honest, she's a typical teenager. She still doesn't turn lights off, but it is what it is. But they do understand, and I think that's quite important. And we have to remember that we've had it really, really easy for a very, very long time. Almost a social engineering project in itself, to get people aware of energy conservation and energy usage. But the next generation will know better, and the generation after that will know even better than that. And, it'll become the norm.
Well, thank you so much, Simon. You have just spent such a wonderful amount of time with us today, educating us on solar and batteries and storage and off the grid. And I really it hopefully has given everybody a better insight into their options and given them some real serious food thought. So thank you very much for your time.
Thanks,
You're
Simon.
welcome. Okay, thank you.